Okay, let's start. My name is Erwin de Gier. I'm from Amsterdam. I work in Sogeti, Netherlands as a developer. And one of the things that I like working with the most, and I also like my free time, is an open source project called Vert.x. And before we start, I think I need to know how far you are with Vert.x. So, does anyone know Vert.x? Have worked with it? Uses it in a project? Okay, no, we know the level of detail to go into. So first of all, if you go to the website, it says something, Vert.x is a toolkit for developing reactive applications on the JVM. And what they mean by this is that it is a complete environment for building lightweight reactive applications. So you can use it together with Java Enterprise or with Spring Framework, but the intention is that you use it separately from other big frameworks that dictate how your architecture looks. So basically, if you build a Vert.x application, you're building a runnable jar with all the dependencies in it. And one of the driving forces behind the development of the Vert.x project was the Reactive Manifesto. So how many of you know the Reactive Manifesto? 2? Okay, so let's go over it. If you go to the Reactive Manifesto website, reactivemanifesto.org, they say that the Reactive Manifesto is an answer to the requirements we see for our software. So requirements around a lot of data. Users always want to be able to access their information, distributed systems. And they say basically there are 4 traits that you need to have in your application, in your architecture, to be able to call it a reactive system. Those are elasticity, so it has to be elastic. So you should be able to scale up and down modules in your system. It has to be responsive, so you should always get feedback, even if there are failures. So it should also be resilient. So if certain modules fail, you should still be able to use part of the application. And it should be message-driven. So asynchronous messages are used for communication. So if you look into how Vert.x is built and how you build applications with Vert.x, then you recognize all these traits. Another interesting thing about Vert.x is that it uses multiple languages. So they have an API to use the utilities inside Vert.x, and they basically start with a Java implementation, and based on the Java implementation, they generate APIs for other languages. So you can use Groovy, Ruby, JavaScript, Ceylon, Scala, Kotlin, and this makes it really versatile if you have a development environment and people are not a Java person by default, or they want to use another language to develop their functionality. And finally, the last one is distributed, and I will go into detail a little bit more with that one. So the intention is to use it separately as a complete solution for your application, and it also means that the technology stack includes all kinds of functionality. So you can build REST services, there are adapters to use different data sources, like MongoDB or Redis, but also legacy JDBC drivers. But there's also a lot of integration stuff, a lot of protocol supported. They have solution for metrics. Actually, they use the drop wizard metrics. And there are integrations with stuff like Zookeeper, Hazelcast, and Kubernetes. And what I also like is if you think about asynchronous applications, they should always be asynchronous front to back. So from the click in the browser all the way to your data store or your file system, everything should be asynchronous. So within the Vert.x project, you will find asynchronous JDBC drivers. That means you can fire a query, do something else in the meantime, and when the result comes back, it's processed. So your thread doesn't block on the query, but it's free to do other stuff. Same goes for MongoDB, but that already has an asynchronous Java driver. But also for calling other web services, for writing files to the file system, everything is asynchronous. So this model of asynchronous behavior, it's called the reactor pattern. and it's also the same which is implemented in Node.js. So if you know Node.js, actually there's one thread processing all your application logic, and for that one thread, your application is optimized to, when there is any long-running work, the thread is not blocked, but it's either running on a separate thread or it's an external system doing its processing, and you use callbacks to further process your information. So all the application logic you write is asynchronous. And this is an optimization. With Vert.x you can use your processing power efficiently because of the asynchronous model. Of course, when you start developing your software, you always run into cases where you cannot do asynchronous processing. So there's also utilities for using separate threads, for instance. Everything in Vert.x that does something is called a vertical. So if you have maybe a small REST service, you write a vertical that implements its functionality. And if you need to do any stuff on another thread, it's called a worker vertical. So maybe you have to call a legacy database. And with a legacy JDBC driver, and this is synchronous communication, you can offload it to a separate thread. There's also more interesting stuff like automatically the amount of instances of each vertical is scaled to the amount of threads available. So if you have an 8-core CPU, you get 8 instances of your vertical automatically. So that's the asynchronous model. Another unique trait, I think, is in the distributed nature of Vert.x. Basically, if you deploy your verticals and you communicate between verticals, you use messages. And by default, these are JSON messages over TCP/IP. And the mechanism that you use to send the messages is called an event bus. And if you deploy in one JVM, it's just an in-memory thing. So you send your messages and it's in memory. But if you deploy on multiple JVMs, it automatically creates a network, a cluster of nodes, and the event bus becomes distributed. So if you have an ideal network where multicast is allowed, so say for instance your laptop is on the same network as my laptop, I run a vertical here, you run a different vertical or the same vertical, they will automatically find each other using multicast join, which is a Hazelcast function, and we are able to send messages. So without any configuration, if your network allows for it, you already get this distributed nature and you are able to send messages. You can even extend the event bus to the browser, so you can connect to JavaScript clients and you can do push to the browser, and it uses WebSockets or it uses a fallback method if your browser doesn't support WebSockets. So this is the basic functionality of Vert.x. So polyglot, reactive, and distribution. And if you look further down on the website, it says Vert.x is ideally for creating lightweight web services or microservices. And this was interesting because last year, end of last year, in the fall, there was a Vert.x Core Developer Day in Amsterdam. And all the contributors and the core developers of Vert.x got together 2 days at the Red Hat office. And they invited some users and people from the community, so they invited me as well. And we talked about, if you build microservice solutions and you use Vert.x, how do you use it? Because if we think about microservices, we think about REST, basically. And the underlying communication in Vert.x is JSON over TCP/IP. So this is a bit different from the regular microservices. So we looked at all the stuff that's inside the Vert.x stack that make people use Vert.x as microservices, because if you look at how it's used in different companies, they use it for microservice architecture. So there's a lot of integration. So if you have to do integration with REST or other protocols, it's really easy because it's all supplied and it's also asynchronous. You get the messaging out of the box. It has distributed data structures. So for instance, if you have to share your session data over multiple nodes, you can use the same mechanism that's used for the messaging. So underneath it uses Hazelcast, which is like a distributed key value store. And if you use it in an environment where you need to share your session data, you can deploy it on different nodes and you can share that session via one big distributed map. so you don't need sticky sessions or stuff like that. But it also has load balancing features, so you can deploy different kind of configurations on different nodes. So say for instance, if you have a web shop and you need 2 instances of your product service, but only 1 of your order service, it's really easy to do this with Vert.x. And you can even do it on different machines, and the applications don't have the same. And they also have stuff like failover, so if one node is running on, one instance is running on one machine, but the machine dies, even if it's not running on the other machine, Vert.x can spin it up for you. So you can have different applications on different machines, and even in the high availability environments, Vert.x can ensure that your nodes stay up, or at least one instance stay up. Do you have a question? Okay, I thought you were raising your hand. Also, they have a lot of tools around monitoring, metrics, and deployment. Today's Tuesday, so last week, exactly 1 week ago, version 3.4 came out. I have one slide with a little explanation about what's in version 3.4. This talk was based around 3.3. And in 3.3, they added more microservice-related features. And the first one is the support of circuit breaker pattern. I don't know, who knows the circuit breaker pattern? Yeah, it was described in the book Release It by Michael Nygaard, I think. Is that correct? I see you nodding, thanks. Okay, so at one of my clients, a bank, they said, we have people working on front end on the website, and they use JavaScript, and they don't know any Java. And every time they have to build a web application, they need to call some APIs. But to get the correct information, they sometimes needed 3 or 4 APIs to call from their client code. Because those backend APIs are, for instance, just an overview of your account, or all the transactions of the past week. But in the front end, they needed all the transactions over all the accounts, over all your cards, and they need them ordered by different like date or amounts. So that there was a big gap between the backend APIs and the front end APIs. So they said, can you give a little introduction about Vert.x? Because what we want to do is we want to enable the front-end developers to use JavaScript to create a mapping from the front-end API to the back-end APIs. And because Vert.x supports development in JavaScript, but you can run it in a Java JVM environment, this gave them the ability to let front-end people develop their own micro APIs to call the backend APIs. So that was really, for them, a case where Vert.x suits really well. And also because it's asynchronous, they can call multiple APIs at the same time, and then when they get the results back, they process it, transform it, and order it. But if you call backend APIs, of course, there can be failures. You can have a failure that you don't get the result you want, or you get a timeout because the services are not available. And if you have these distributed systems, what can happen is a failure in one API or a failure in one node can cause failure in the other nodes because they are waiting for it, or their exception handling doesn't allow for timeouts. So this is where the circuit breaker pattern comes in. So what it actually does is it emulates a circuit, and when the circuit is closed, then everything is fine. From service A, I call service B, and I get a response, and the circuit is closed. But what happens when I don't get a response? You don't want to keep retrying, because you can overload the service you call. So what happens is you can set an amount, for instance 5, and after 5 tries, the circuit opens, and the backend service is not called anymore to give it room to recover, for instance. Maybe it was an overload of requests. After it is opened, it doesn't call the backend service until a certain timeout, and then it tries only once. And if it's still not reacting, it stays open, but if it reacts, it becomes closed again. So this mechanism allows to prevent failure in one service in the other service. So how does this look in code? Basically, is this readable, by the way? Yeah, in the back? Okay. So basically, you can create, with use of a Vert.x API, you create a circuit breaker. You can set the max failures. So if you have 5 failures in this instance, the circuit opens. The timeout says, okay, after 2 seconds, I want to try again. I want to allow a retry. And you can call error handling code. Maybe instead of having a real result, you have a default result or a static result. And a timeout for when the circuit is reset. And then you do your backend call inside the breaker.execute function. So I have a demo of this. Okay, so if you haven't seen any Vert.x code, this might look a bit different from what you're used to. But basically what we're doing is we create a web server. And when the web server is called, it calls a backend service and returns its results. So if everything is okay and you call the result, it will give me a response. No, it doesn't, yeah, it zooms. So this is in ideal situation. So we call the first service, it calls the second service returns the result, the first service returns the same result. So now when the backend server goes down, so we stop that backend servers. I think I have to call it 3 times because that's the failure rate. So after 3 failures, yeah, 1, 2, 3, the first 2 were correct. It says circuit opened and it doesn't call the backend service anymore. So it will call it after a certain timeout, and then if it still doesn't respond, it stays open, and if it will respond, it is closed again. So if we restart the backend service, and we run it again, it will immediately give me a result. So this is a mechanism, and it's a pattern which is widely used if you do these integration scenarios, and now within Vert.x, you get it out of the box. So it makes it really easy to implement this pattern. Okay. Next thing, which was added in 3.3, 2 microphones, is service discovery. So if you have a microservice environment and you frequently need to call one service from another service, what of course you can do is you put the URL of service B inside the configuration of service A. But what happens when you swap out the service from a different service or it gets deployed in another environment? So basically, how you solve this, instead of having hard links between services, you use a service registry. And inside the service registry, every service provider registers itself, and you can do this by name or by URL. And they say, this is what I provide as my service, this is how you can find me, and this is my name. And if you need to call that service, you can query the registry. And the easiest thing, of course, would to do it by name. If you have a naming convention, you just apply the name. But there are different methods of querying as well. A registry also allows you to handle scenarios where services are unavailable. So you can publish and unpublish. So you can have a dynamic landscape of services and the registry makes sure that you can find the services wherever they are deployed. And if you think back about the services being able to find each other, that works in ideal scenarios. So if you have multicast allowed on your network, your different verticals can find each other. But in a lot of cases, this is not possible. For instance, if you run your services in Docker, they are already in a network environment where they cannot find each other. Or when you run it on a cluster, like on a Kubernetes environment, you need to have a different method of discovery. And that's why the service discovery and the service registry, it's extended by a bridge, and you can use an external registry. An external registry can be the Kubernetes registry, or it can be the Zookeeper, for instance. So you use an external method, and one more thing you can do is you can mix with non-Vert.x services. So say, for instance, you have a REST service, and it's built in Node.js, or it's built in another Java language. They can register themselves in Zookeeper or in a Kubernetes registry, and with use of the bridge, from your Vert.x verticals, you can find these REST services. So you can import and export services with other registries. So if you look at the example, this would be a service client. So this vertical wants to call another REST service. And what they do is inside the service discovery API, they look for a record by name. So in this instance, it's example REST API. And if the service is registered in the registry, it will actually get back a reference to the service. And because we know it's a REST service, in Vert.x you can create a HTTP client out of it, and directly on the HTTP client you can make all your requests. So on this client you can do a GET request and a POST request, and so without knowing the URL or the IP address of the external service, the service registry provides me with an instance of a HTTP client that I can use to call the other service. So if I run this, it should actually fail because I only have the client running. So the result was not successful, so I print out no service found. So if I start up the server vertical, and let's have a look at it first. So the server vertical is a plain REST service. It also gets an instance of the service discovery API, and then it publishes itself by name. So with the combination of the name and the URL and the port, it publishes itself in the registry. So now, when I run those together, it will find the service, it will make an HTTP request, and you get status code 200. So this is a way of dynamically discovering services without hard linking them together. Okay, so I just discussed or explained the scenario where you can use multicast to find the different modules in a Vert.x cluster. If that's not available, you could use IP addresses. So it uses Hazelcast. Hazelcast has an XML file called cluster.xml, and inside that XML file you can just put an IP address and say the other service is running at this IP address. But then when you have a microservice environment where you just dynamically deploy and even if you use Docker, you don't even know the IP addresses. They just get assigned randomly. So this scenario is not a feasible scenario. You probably won't even use static IP addresses to do the service discovery. So again, we can use a service registry, but instead of using a Vert.x registry, you can use something like Zookeeper. Does someone have experience with Zookeeper? Yeah, ooh, a lot of Zookeeper experts. So the mechanism is the same, but instead of the Vert.x API, the verticals publish themselves inside the Zookeeper registry, and if you want to find the other verticals, you have to call the Zookeeper registry, and you will get the references back. But you don't have to do this by hand. It's all handled automatically for you. So if you look at the configuration, it does look like a lot, but it's actually only two things that are important. First of all, you have to tell Hazelcast that you want to use Zookeeper. And second of all, you have to specify where Zookeeper runs. Well, in this demo, I use Zookeeper inside Docker without any configuration, but normally this would be a URL and your DNS would handle the translation to the IP address. So all your verticals or all your application nodes only need to know where Zookeeper lives. I just use a plain Zookeeper Docker image because I'm actually not really experienced with Zookeeper. So I did nothing. I just started a plain Zookeeper image. No configuration. And I start my fake product service. And what you see is it deploys the vertical, it creates a cluster, and the cluster now has one member, and that member is published in the Zookeeper registry. So if we add another member, for instance, the webshop frontend, what it will do is it will try to connect to the Zookeeper registry, and now the cluster is extended to two nodes, and the two nodes are able to find each other, and this one, it sends periodically, it sends a message, and the other one should receive the message. So it sends hello, and the other one receives it. So both instances of the vertical only have the address of the Zookeeper instance, but you're still able to automatically create a cluster of nodes. So normally this works without any Zookeeper on your local machine or on your local network, but even on our company network this doesn't work because you are not allowed to do multicast. So you need a mechanism like this to be able to find these services. Okay, so this is just local Docker on my local machine. But if you're running a microservice architecture, you probably use a Docker orchestrator to create your cluster and to deploy in your cluster. So say, for instance, we have multiple services, and each service has its own amount of instances because users use a product service way more than they use the order servers. We need more instances of the product servers than of the order servers. So we have this landscape with different amounts of instances of our different services. And in my example, I use OpenShift. OpenShift is the Red Hat stamped version of Kubernetes. And Kubernetes also has a registry, and in the same way as with Zookeeper, we can use Kubernetes to do our service discovery. So you can actually do this at home. If you want to do anything with a cluster, you can run it completely on your own machine. And if you look up the documentation, it should be really easy. You install the OpenShift terminal client, and then when you say OC cluster up, it creates a complete OpenShift cluster for you on paper. But I actually tried to run this demo Thursday. I was leaving on Friday morning really early to fly here. So I thought, let's go over the demo once more. I updated my Docker. Last week or 2 weeks ago, Docker native app 1.17 came out. So it gave me a lot of errors when I tried to run this command, and a lot of stress on the Thursday before flying out. So I had to figure out a lot of stuff, and apparently if you have the right configuration of versions, it works. So basically I had to downgrade the Docker app to 1.13, which is pretty hard to find because they don't have a release with all the old versions, but it was somewhere in a GitHub issue. You need the OC client 1.5, and that's I think the latest if you install it. And we're going to install OpenShift 3.4.1.5. And this is the command you use. It's possible to do it during a presentation, but it depends on the internet connection how fast it is. So I ran this morning because I didn't want to run in the situation where we're just waiting minutes for this to come up. But basically, if you use a Mac, you can use brew and you can install OpenShift CLI. When you run this command, it will create an OpenShift environment for you. And the next thing you want to do is log in. Is this big enough? I guess so. So it's running because I can log in. And it shows the projects you have inside Kubernetes. So I don't know if you're familiar with either Kubernetes or OpenShift. No hands. One hand? Not? Okay. So this could look familiar. So basically when you log into the web, it shows you projects. I only have one, which is Vert.x. And what I did is I deployed one service, and it's currently running one instance of that service. And let's have a quick look at the service because it's really simple. So basically, I create a API which just says hello, and I have a bridge. I bridge my event bus to the browser, so I can get push updates in the browser. And what I actually want to show is just, I'm going to deploy this service several times, and it publishes an hello message and the IP address. And it pushes this to the browser using the event bus. So if you have one instance, the way to deploy it is, if you have used OpenShift, you may recognize this, but basically inside OpenShift, there's a build called source to image. It takes a Docker file and a GitHub repository, and it pulls the code from the GitHub repository, it merges it with the Docker file, and it creates a container for you. So the Docker file I use, it's made by CodeCentric, and they basically do a Maven build, and then they run all the jars resulting from that build. So that's really easy if you want to quickly deploy something on OpenShift, and you don't want to do any configuration with templating or otherwise. You can use this image. It was created for Spring Boot, because Spring Boot is, of course, a runnable jar, but it works with any other runnable jar too. So we can use it for Vert.x, you can use it for Drop Wizard. And the second thing, it needs a GitHub repository. That's my GitHub repository where we're looking at now. And you can give it a name. So once you run that command, which I already did, it will create a service. You can expose it in a URL. This is really small. And basically, we have one service, one instance, and it just publishes one IP address. So within OpenShift, of course, you can scale. So if you have multiple instances running, eventually we should see another IP address. So now we have .2 and .3. So that's 2 instances of one vertical. The verticals use Hazelcast and Kubernetes registry to find each other. So if you look at how the configuration looks, it's similar to the Zookeeper configuration, but now we're using a Kubernetes discovery strategy. And we don't even have to specify where the Kubernetes registry lives, because there's an environment variable. It's called Kubernetes namespace, I think. And namespace is basically coupled to your project. So within a project, all the services can access that namespace, and they're published under that namespace. So by default, everything you deploy in the same project is able to find each other. If you have services in different projects, you need to configure different namespaces. So you need to do some custom configuration. But if you just want to run the cluster for POC or something else, if you have one project in OpenShift, everything you deploy there, it can be found using the Kubernetes API. Some other stuff to, if you want to try this, of course, this is in GitHub, so you can have a look. But it took some figuring out. Apparently, you have to give the services access to the Kubernetes API, and you need a command like this. So this command says, this namespace is accessible for all the services inside this namespace. So this really doesn't tell us anything, because I just heard in the previous session you need at least 3 instances to test most integration scenarios. So let's deploy another one. So basically we already used the Docker file once, so we can just specify the name of the Docker file. Inside OpenShift, something called an image stream is created, and that's actually a build of a Docker file. So if we run this, it will actually start a new build for us inside OpenShift. So this is our second service, and now it's currently doing the Maven build, and then it will do the deployment. And then we have another container with another instance running inside. And, oh, it's pretty fast. That's good. So currently we have those. Or is it just slow? Currently we still have those 2 IP addresses. This might be too small or not. Eventually, when the build finishes, it should show a 3rd IP address, which is the new service I deployed. And then we are at 3, I think. So that should be enough. Yeah, so now there's 3, 2, and 4. So if we go back to OpenShift, we see we have 2 services. One has 2 instances, one has 1 instance. And they don't know each other IP addresses. They publish themselves in the Kubernetes registry. And Hazelcast makes sure that they form a cluster together. So no hard links, and now you have a dynamic environment to be able to dynamically deploy new services. So this is really basic, but if you think about it, this allows you to create new services dynamically, scale dynamically, bring down the services dynamically without having to change the configuration of all the other services. So within the Vert.x environment, this is really powerful, but also remember, if you have any other REST services, you can deploy them inside Kubernetes as well. And they will also be imported by Vert.x, and from Vert.x you can call them. And it also works the other way around. Okay, full demo or full source code is in my GitHub repository. Any questions so far? Yeah?
When two services, so through the registry, when the service discovers another, is there also a mechanism to pass any information which service A may need some information to talk to service B, other than just a soft link, like some sort of like binding?
Yeah, so the question is, can you pass other informations via the registry between services?
Right.
Right. Yeah, it's
like a handshake, initial handshake, or this is how you use me, or some information.
yeah. Actually, the concept that is used inside Vert.x is called a record for this, and you can put more information in the record, and you can also query more information in the record. So you have some more freedom there. I don't know by head exactly what you can put in there, but so if you don't know if it's a REST instance, you just get the record. And based on the record, you can do more stuff. So you can look inside the record, the service record, and you can put more information there. So you have some freedom. And there might be just a field to put JSON.
And sounds like metadata, but also, I don't know, I'm sure Kubernetes has this too, but it's kind of like more of a provisioning. So if you think of the next step, one is finding a service, the other is, think of, let's say, Postgres, for simplicity. Right? And I want to create, not only I want to find Postgres, but I want to provision a new logical instance of the store. So when I do that, I get back some schema name or some like a runtime information. It's more like a broker, like a service broker, but it's an extension of registry. I don't know if you could.
Okay, so yeah, so your question is, besides the metadata, can you put more information that also allows you to create?
Yeah, it's like a logical provisioning of a service.
Right? Okay.
Because if you have service A is going to use service B, let's say it's a multi-tenant service, right? And I want to find it, but then I also provision or instance of that service to use.
Yeah.
Because it's a shared service.
Yeah, that's actually a really good question. I don't know that by head. I haven't seen it in the documentation, but we can have another look afterwards to see if it's there, because that sounds like a really good use case. So that's basically you want to provision a service or explain the usage to through the registry.
It's like if you're familiar with Cloud Foundry, for example, it's like service broker.
Yeah. Okay. Okay.
Service broker is a registry and a broker.
Yeah. One more. And Kubernetes allows this.
I'm guessing. I use Cloud Foundry, so
Yeah.
they may have a similar pattern.
Okay. Okay. Good question, but I don't have the answer. Sorry. Okay. Next up is HTTP2, and I realize that those are not the best colors for readability. But basically, if you look at HTTP2 versus HTTP1, it allows the requests to be processed asynchronously and out of order, and it also allows multiplexing of different requests. So if you work with a completely asynchronous system, what you notice is that HTTP is really restrictive because it's completely synchronous request-response model. And you can, for instance, use something like WebSockets, which allows you to do more like an event-based communication. But the thing about WebSockets is it's really basic. It doesn't give you anything. It just gives you a similar TCP IP connection, and you can send stuff over it. So HTTP2 is what we were waiting for. It allows you to do more stuff like HTTP1 with headers and a body, but it allows you to have a more asynchronous communication with messages. So in 3.3 version of Vert.x, you can create an HTTP2 server and you can create an HTTP2 client. And it allows you to do stuff like server push. So you can actually just push stuff to the client without getting a request first. You can do request pipelining and multiplexing, which means you have full duplex asynchronous communication. So you can implement a messaging model or an event-based system. And it also allows you to send and receive custom frames. So HTTP 1.1, it's quite, the messages are quite big. If you have a lot of requests and responses going back and forward, you will notice that the HTTP messages are quite big. And with custom frames, you can just describe your own frame and send it in a binary format. So if you do more like a real-time system or for gaming, or there's a lot of communication between client and server, it allows you to just send basically binary format. Yeah.
So you mentioned in the beginning there's the event bus.
Yeah.
So does the event bus use the HTTP2 now as well?
You can, that's actually a really good question. Okay, so the question is, does the event bus uses HTTP2? If you're looking at server side, then the answer is no, because it uses Hazelcast and TCP/IP. If you look at the bridge to the browser, it uses WebSockets, and I don't think they use HTTP2, but I expect, if you look at the way they're working, they will just include that as an option for the bridge. So they will check with the browser, do you support HTTP2? Yeah, I use HTTP2. Do you support WebSockets? No HTTP2, WebSockets, and then fall back all the way to long polling. But I don't think that's there yet. So that's really good question. So HTTP2 in practice. So if you create a HTTP server in Vert.x, there's not an option set HTTP2 true. It's called set use ALPN. Currently, it's false. So if I start this server, then we're using HTTP 1.1. So I have a HTTP server, and if I go to the /version URL, it will give me back the HTTP version. So now I know I have HTTP 1.1. And actually what the server implementation does, and this might be a demo you have seen before, if you have seen other HTTP2 demos. It actually builds up an image based on small images. So it will call an array of XY coordinates, and it builds up a complete image. So each part of the image is a HTTP request. And this is actually a really good demonstration of how HTTP2 works. So if you have each image is a separate HTTP request, and you use HTTP 1.1, it takes about 8 seconds to build up the image. That's because it's completely synchronous. So request, response, request, response, request, response, until we have the complete image. So if you enable HTTP2 and we restart, so first check the version is HTTP2, so now we know it's going to work. And what will actually happen is that it will combine the request responses, and they can do it out of order. And the performance increase you get is, well, this was about, I think, one or 2 seconds. So this is the big difference what you can do with HTTP 1.1 and HTTP2. Of course, you won't building up an image like that, but imagine that it's a lot of data, maybe data on a map, amount of hotels, or the prices of hotels on a map. Then you're able to send more data a lot quicker. I can close this. So that's one thing you can do with HTTP2. Another thing is server push. And if you look at the API, it's called push, and it enables you to send stuff to the client without a request. So if you have a website with real-time information, you don't need WebSockets anymore to update that information, you can use HTTP. And in the client, I have to register a push handler, and currently I just log the stuff I get pushed. But of course, this is not a browser, this is just HTTP client. So it will work with HTTP services, backend HTTP services as well. So if I deploy those two together, it will start a server, it will send the data, and at the client side the data is received. And I log the version. So actually when you think of it, if you're building an asynchronous system, if you do it now, you're constantly running into browser communication, REST communication, still synchronous. With HTTP2, it allows us to do more like an event-based system. So we can actually push information to other services as long as they are registered over HTTP. And the final thing is we can send custom frames. So here it's just a buffer that says ping. And this is the server side. The server side, we define a custom frame. And once we receive the custom frame from the client, we send it back to the client. And now we have like a ping pong implemented. So if we start those two verticals together, then the client sends a ping and the server sends a pong. So now we have custom data over HTTP2 sent between two services. But those two are verticals, but of course they can be any other Java services or the other non-Java services, because it uses just HTTP2. No event bus, no Hazelcast, just HTTP2. So we also already get this support inside Vert.x. So last week, we already got 3.4. I was actually hoping that it would be released a little bit earlier so I could incorporate some 3.4 stuff inside my talk, but that was not the case. So quick overview. For the first time, we got Scala and Kotlin. So next to JavaScript, Ruby, Cylon, we also have Scala and Kotlin now as supported. There's a nice new web client. It was kind of cumbersome to do HTTP client requests inside Vert.x, but they reworked the whole API, and now it's much more easy. You can easily send JSON or receive JSON and automatically get an object out of it, instead of having to send low-level HTTP requests. MQTT, it's an IoT protocol, which is pretty elaborate. It's for small messaging between devices, because you can use it on low-powered devices. And it actually has different service levels. So you can say that messages should be sent only once or at least once, or you want to have a confirmation that your message is received. But you can also just publish and forget messages, depending on what kind of service level you want. And there was an open source project, Vert.x MQTT, and they actually incorporated that. And now in the new version of Vert.x, we get an MQTT server. And what's nice about this is that you can deploy this, and it will actually translate MQTT protocol messages to your event bus. So you can have a vertical handling some kind of logic, and it just receives JSON and it sends JSON. And with the MQTT broker, you can connect your devices, and the devices will be able to connect over the event bus with Vert.x verticals. So you don't need any other mechanism to do the MQTT. You can just use it as part of your Vert.x deployment. More integration, for instance, with Kafka. So if you look at it, I think the amount of integration possibilities with Vert.x that you get out of the box makes it something that makes it really stand out among other. projects. You can really get a lot of asynchronous integration, and they're still expanding those integrations. What I saw at clients is the case I described. They want to have JavaScript developers doing a little API stuff on the back end, which is easy because you can code in JavaScript or other languages. Service discovery, it was something that was much needed because you don't want to have the hard links between your services. And one of the first, I think, HTTP2 implementations in a bigger framework. So if you're interested in Vert.x, there will be 3 other talks in this DevOps instance. Tomorrow, event-driven microservices with Vert.x and Kubernetes. And Thursday, I think that's a hands-on lab. One of these 2 is a lab, and the other one is a presentation. So a lot more Vert.x goodness if I triggered your interest into Vert.x a bit. Any questions? Yes?
Can you tell me a little bit about how long it's been around, the project, and anything about like the maturity level, adoption?
Yeah. The question was, can I talk a little bit about how long is Vert.x around and what's the maturity level? If I remember it correctly, it was started by Tim Fox 3 or 4 years ago. It was called Node.x because it was an answer to Node.js. So Tim looked at the functionality and the reactor pattern, how it was implemented in Node.js, and he said, this is a really, really good idea, but we want to run it on the JVM. Because our operations, they don't want to run JavaScript on the back end. It was a couple of years ago, of course, we have moved on, but we want to have stuff running on the JVM because we know how to operate it, we know how to log it. So I want to have a similar project written in Java. Along the way, there was a little fight, I think, between VMware and Red Hat. They both wanted to have the project, and Red Hat got it. So it's now a Red Hat sponsored project. So there are some core developers from Red Hat actively working on Vert.x. Tim has left the project. He's now a user. So it was really funny because he was also at that meeting end of fall, but he said, yeah, I'm now here as a user. So that's a completely different view on the project. What I think of is, if you look at the technology, it's really sound. It's well thought. They have some principles, like they want to be unopinionated. So they provide the full stack and give you the possibility to do the implementation. But there's not a lot of marketing around it. I know some companies in the Netherlands and some companies outside the Netherlands who use it, but it's not frequently heard. But if I compare it to similar solutions, I think we have Node.js, could be a candidate. Spring Reactor might be a candidate. Akka, if you want to do Scala, but it's a little bit more low level. And that's about it. I currently use it now in one project for one of our clients, and we are going to use that software at different clients. Version 3 was a little bit different from version 2. So version 2, they had the whole own class loading model and became kind of complicated. And in version 3, they said, we are just going to use Maven dependency, flat class path, fat jar. So that also means if you run a Vert.x environment, you can use a Maven repository to deploy your verticals. So you don't have to manage all the code by hand or put it on different servers. You can actually pull new instances or new versions from a Maven repository. So you deploy to the repository, and with a command line or an automated script, you say, okay, there's a new version, or I want to pull a different service. Is that the answer?
Yeah, thank you.
Okay. Any other stuff? No? Thank you very much.